Hey, welcome back to our AP Calculus video series. Here are a couple examples of limits, calculating limits, using our limit laws and our limit rules. Here are some of the problems that typically throw students off. Things I want to point out here are, I've got something that's in the general form of some variable, some u, some term, we'll call it u, minus 1 over h. As h approaches 0. Whenever you've got something minus 1, we want to do something here to multiply by a conjugate. So whenever you see this structure, something minus 1, think conjugate, that conjugate pair. We'll see that later on 30 as well. I see something minus a number, so I'll try something plus a number. All right, let's go back to our problem here. I've got the square root of 1 plus h minus 1 over h as h approaches 0. This looks scary, but what I can do is I can multiply by that conjugate, which is the square root of 1 plus h plus 1 over the square root of 1 plus h plus 1. Notice how I did not change the value of this problem, because what am I doing here? I'm multiplying by 1 over 1. So I'm multiplying by 1. I'm not changing the value at all. Okay, when I do that, what am I going to get? I'm going to get 1 plus h square rooted squared. It's going to give me a 1 plus h. The middle terms are opposites, and they will end up reducing, and you end up with a minus 1. Here I'm going to have an h times, and here's where I want you to not distribute. So in these problems, please do not distribute. It'll make the end of the problem a little bit easier for you if you just leave it like that. Because now what do I have? I have positive 1, negative 1. Those reduce, and now I have h over h times the square root of 1 plus h plus 1. And now those are going to reduce. So the reason why I didn't want you distributing this h through is so that we could just very easily reduce it here. In my final form, I'm trying to find the limit as h approaches 0. Now that I've reduced everything, it's 1 over the square root of 1 plus h plus 1, which if I make that 0, that's gone. It's 1 over the square root of 1 plus 1, which I know is 2. So I have a fraction there of 1 over 2. I'm going to go to 30 because it's the same idea. Same idea here. What we need to do, I see a conjugate opportunity. Something minus 5 multiplied by that thing plus 5. Over that thing plus 5. And again, this is just the number 1 in a fancier format, so I'm not changing the value of the problem. I would encourage you, if you struggled with either one of these problems, to pause the video, try to simplify it, and then unpause and check your work when you're done. So what happens here? I end up with x squared plus 9 minus 25 over, and again, we want to leave this undistributed. Do not distribute this through on the denominator, just copy it down. because it's going to come in handy later. So that would be what I get there. I can simplify that as x squared minus 16 over all of this stuff. And because I remember my algebra, I can simplify this as x plus 4 times x minus 4 in the numerator over that same denominator, and this is why we didn't distribute earlier. The reason why we left this part out was so that I could reduce it now. And I have this x minus 4 over the square root of x squared plus 9 plus 5. And we wanted to take this limit. Now, I can take this limit because there's no domain restriction anymore. But I wanted to take the limit as x approached negative 4. So that's why I needed to get rid of this. That was the big problem, was this x plus 4. So now that I've gotten rid of that, I'm all good. And I can say this would be, if I wanted the limit as x approaches negative 4, this would be a negative 8 over 10, which is the same as negative 4/5 or negative 0.8. I'm sorry. Yes, that's right. Yeah, that's right. Okay. So anytime you see something that is of this structure, something minus a number, some square root, some squared, something minus a number, try multiplying by the conjugate of that thing, because you're probably going to use that to get out of that jam. 24 wasn't too bad. 24, all I have to do is split this up and say this is x plus 1, x plus 1. I can split up the bottom as x squared plus 1, x squared minus 1. I can split that up as x plus 1 up top still, over x squared plus 1, x plus 1, x minus 1. I can reduce one of those and I get x plus 1. X squared plus 1 cannot be simplified. X minus 1 cannot be simplified. That's my final function. That's my simplified function. And I wanted the limit as x approached negative 1, I believe. Yeah. So if I want the limit as x approaches negative 1, now I have no domain restriction at negative 1. This would be 0 over, this would be 2 times negative 2, 0 over negative 4. That limit's going to be 0. So the big things you need to take away from this problem are just remembering how to undo your difference of squares. And our very last question of this type in this area is, I'll do it in pink. This one's a little bit tougher. I've got the limit. Let me get rid of this real quick. Move this down. All right, I've got the limit of 1 over t minus 1 over t squared plus t as t approaches 0. So I've got two different issues there. But let me see what I can do. I've got 1 over t minus, now let me factor out a t. When in doubt, see if you can factor out t plus 1. I can see that these are pretty close to being similar. So here's what I'm going to do. Let me see if I can get this denominator to look like the more complex denominator. How would I do that? If I multiply by a t plus 1 on the top and bottom, now I've got like denominators. And now what I can do is I can simplify this t plus 1 minus 1 is going to give me t. This is going to be t over t times t plus 1. And now that I've got those like denominators, I was able to simplify the numerators. I can reduce that, and I end up with a 1 over t plus 1. And now I can plug in a 0. Now I can substitute in 0 for t. So the limit as t approaches 0 of 1 over t plus 1 is going to be 1 over 0 plus 1, which is just 1.